This is worksheet 27.1, and we're going to look at number 6 through 9, which is based off of the empirical rule. So we're going to define the empirical rule, and it's based off of the normal curve that we saw in number 2. So the empirical rule, a short way of writing it is just 68-95-99.7. So what those numbers represent are percentages. I'm just going to split this into 3 parts to describe those 3 numbers. So the 68 represents the fact that 68% of the data fall within 1 standard deviation. The 95 represents that 95% of the data fall within 2 standard deviations. And then the 99.7 represents that 99.7% of the data fall within 3 standard deviations. So based on that, if we look at this normal curve, each of these sections between the standard deviations is split up into certain percentages. So if 68% of the data falls between 1 standard deviation of the mean, that means 68% of the data is between this dotted line and the one up to the left. So that means 68 divided by 2 is 34% is on this side of the mean, 34% will be on the left side of the mean. Okay, we also know that 95% falls within 2 standard deviations. So if we divide by 2, so 95% divided by 2, 47.5% of the data falls within 2 standard deviations. So if we're splitting that into 2 parts, so divide that by 2. Actually, we already divided the 95 by 2. So we already know that half of it is 47.5. But if we want to label just this section between the first and the second standard deviation, I'm going to subtract 34%. So I have 13.5% left on this side and 13.5% left on this side. And then lastly, 99.7% of the data falls within 3 standard deviation. If I divide by 2, that means there's 49.85% on either side. So if I subtract the 2 percentages I already have, the 13.5 and the 34, I'm left with 2.35%. And same thing here, 2.35%. And then the last part left is anything past the 3rd standard deviation, which is very small. So far we've covered 99.7% of the curve. 100% minus 99.7 leaves 0.3%. So on either side of the curve I have half of that. So divide by 2, 0.15% over here and 0.15% over here. So based on this is something that would be helpful to have on your stamp sheet or anywhere where you're keeping notes, because we're going to use these percentages a lot. So considering the same problem, number 6 is asking what percentage of babies will weigh between 6.3 and 7.6 pounds. So between the mean and 1 standard deviation, this is already labeled 34%. In question number 8, what percentage of babies will weigh more than 5 pounds? So right here we're at 5 pounds. More than 5 pounds would be anything past this mark. There's a couple ways you could do it. You could say that this is everything including the 13.5 plus the 34 plus everything to the right of the average is going to add up to 50%. So the total is 97.5%. You could also think of it as 100% minus these 2 that are not more than 5. So if you did 100% minus 2.35 minus 0.15, then that's 97.5 as well. On number 9, the question is asking the middle 95% of babies will weigh between what two weights. So we already know to look for 95%, which is within 2 standard deviations. So if you start at the mean and go 2 standard deviations out, you can see that the baby weights are between 5.0 and 10.2 pounds.